Okay, this is Unit 11, Notes 3. Today we're going to be solving trig equations algebraically, Day 2, and this one we're going to be using factoring. We're going to focus on factoring today. So, first of all, our goal today, as it was yesterday, is to solve the equation by isolating the trig function. We still want to isolate the trig function. We must use good algebra. We must use good algebra techniques to do this. Do not get lazy with your algebra. Okay? The hardest part of trig is probably the algebra. Okay? Just like the hardest part of calculus is probably the algebra. Alright. Number 1, isolating the trig function by raising each side to a power. Sometimes when isolating the trig function, you must raise both sides of the equation to a power. Okay? If you had sine squared x is equal to 1, you would have to square root both sides. That's raising both sides to a power. Remember that when you raise each side to an even root, you must use the positive and the negative of the other side. Okay? So remember plus and minus. Plus and minus. Okay? When this happens, you will need to put your reference angles in all 4 quadrants. Because you're going to have positive and negative values. Okay? Alright. Isolating the trig functions by factoring. Now, as with algebraic equations, we often need to factor a trig equation. Okay? First, we're going to manipulate the equation to get 0 on one side. I cannot tell you how important it is. When you're solving an equation by factoring, get 0 on one side. It is crucial. Do not forget to get 0 on one side if you are going to factor. Okay? Factoring to solve an equation only works when you have 0 on one side. Okay? I know I'm driving that home a little bit, but it's very important. And I can't tell you how many students want to factor before they get 0 on one side. It won't work. Alright? Alright. So, after you get 0 on one side, sometimes you can factor right away. Okay? Look for a GCF, greatest common factor, to factor out. Ask yourself, is there something in common in my terms that I can just factor out? Sometimes that's all you need to do. If you cannot factor right away, sometimes you might have to get your equation to have only one trig function. Either all sines, all cosines, all tangents, etc. You're going to use your trig identities to do that. Okay? Then you're going to treat the trig function like a single variable, say u, and factor. Okay? And then after you factor, you will set each factor equal to 0 and solve for x just like we did yesterday. Let's look at some examples. Alright, number 1. Let's solve this equation on the interval from 0 to 2 pi. So we have this equation. This is an example of I could move the 9 over, get 0 on one side, factor out the GCF, and then factor what remains. I could do that. However, I'm going to treat this, I'm going to, instead of doing it that way, I'm going to divide both sides by this 18. I get cosine squared x is equal to 1/2. At this point, I can square root both sides, right? Our whole goal is to solve for x, but to do that, we are going to isolate the trig function each time. We're isolating the trig function. So to get cosine x by itself, I'm going to square root both sides. When you square root both sides, don't forget your plus or minus. So this will give us cosine of x is plus and minus the square root of 1 divided by the square root of 2. And if we rationalize that denominator, it becomes more familiar to us. Cosine of x is plus or minus square root of 2 over 2. And now we're back where we were yesterday. We ask ourselves what quadrants? Well, it's positive and negative, so cosine is positive or negative in all of 4 quadrants. The reference angle is pi over 4 because pi over 4 makes cosine square root of 2 over 2. So x will be the pi over 4 angle in quadrant 1, the pi over 4 angle in quadrant 2, the pi over 4 angle in quadrant 3, and the pi over 4 angle in quadrant 4. So there are 4 solutions, 4 answers to this equation in between 0 and 2 pi. Okay, number 2. State the value or values of x in between 0 and 2 pi which satisfy this equation. 2 sine x cosine x plus cosine x is equal to 0. Alright, so on this one, I notice immediately that I have something in common. I have a cosine x in common in both terms. So I am going to factor out that cosine x, just like you factored out any other GCF. So from the first term, I have 2 sine x left, plus, from this term, I don't have anything left except for a 1. Keep in mind that if you multiply back, you should get back what you started with. Cosine times 2 sine x, cosine times 1. Okay? So we have factored, it's still equal to 0. So I'm going to take each factor, cosine x and 2 sine x plus 1, set them both equal to 0. This is where it's important that you have 0 over there. If that was any other number, you cannot do this step. It only works if you have 0 over here. Okay? So I'm here and I'm asking myself, what value of x makes cosine 0? What angle between 0 and 2 pi makes cosine 0? I'm thinking of the graph of cosine. That's how I do this. And cosine is 0. Cosine looks like this from 0 to 2 pi. And the x values that make cosine 0 then are pi over 2 and 3 pi over 2. Those are the x values that make cosine 0. Over here, this is our work from yesterday. Sine x will be a negative 1 over 2 after we move the 1 to the right and then divide by 2. Sine is negative in quadrants 3 and 4. The angle that makes sine 1/2 is pi over 6, so I need the pi over 6 angle in quadrant 3 and the pi over 6 angle in quadrant 4. I'm going to write all my answers. So x is pi over 2 and 3 pi over 2 from this piece. From this piece, the pi over 6 angle in quadrant 3 is 7 pi over 6. The pi over 6 angle in quadrant 4 is 11 pi over 6. So these are the 4 solutions to that trig equation in between 0 and 2 pi. Okay? Example 3. Find the value or values of x in between 0 and 2 pi which satisfy this trig equation. Okay, I see a GCF. A tangent x is in common, so I'm going to take it out. I am left with secant x from the first term and a 2 from the second term. So I'm going to have either tangent x is 0 or secant x minus 2 is 0. Alright, so I'm asking myself, what values of x, what angles make tangent 0? Well, I think of the graph of tangent. In my mind, I'm thinking of the graph of tangent, and it goes through the origin. And then it has asymptotes at every pi over 2. So it has zeros. It has zeros at all the pi's, plain pi's, and 0. So in between 0 and pi over 2, x would be 0, pi, and 2 pi from this piece. Over here, I'm going to have secant x is equal to 2. Well, secant is 1 over cosine, right? So this means that cosine x must be 1 over 2. Do a little algebra there. Cosine x would be 1 over 2. Cosine is positive in quadrants 1 and 4. The reference angle is pi over 3 because cosine of pi over 3 is a half. So my angles would be the pi over 3 angle in quadrant 1 and the pi over 3 angle in quadrant 4. So my list of answers would be 0, pi, 2 pi, pi over 3, and 5 pi over 3. Okay? I just realized something. What if, you guys, what if we had a piece? I realized that I didn't give you an example like this. What if we had a piece where it said sine of x is equal to 3 or 2 or something like that? Is there any value of x? Is there any angle that could possibly make sine bigger than 1? Keep in mind what sine looks like. Sine goes like that, right? Sine never goes above 1 and never goes below -1. So there are no such x values that make sine 3. So if you get that on a piece, and on your homework there's a couple like that, where you get something that makes no sense, for that piece then you just won't have any answers. Your only answers would come from the other remaining piece. Of course, it's a possibility that both pieces would have no such x values, and then there would be no solution in between 0 and 2 pi. Okay? Possibly no solution at all. All right. Number 4. We're solving this trig equation from 0 to 2 pi. Okay? So, there is something in common here. However, I don't have 0 on that side. So do not take out what's in common until you get 0 on one side. And after we get 0 on one side, we will no longer have something in common in all 3 pieces. I don't have something to factor out in all 3 pieces, so do not factor out what's in common. Instead, we're going to treat this like a quadratic. We're going to treat this like 2u squared minus 3u plus 1 is equal to 0. We're treating it like that. I don't write it down like that, but that is exactly what we're treating it like. We're treating it like that where u is just our cosine x. If we were factoring this, we would have 2u and u, 1 and 1. My signs would have to both be a minus, to get the positive 1 in the back and the negative 3u in the middle, right? So this would be how that factors. To factor this now, instead of the u, I'm going to have 2 cosine x times cosine x. When we multiply those together, we do get the 2 cosine squared x, right? In the back, I'm going to have 1 and 1 to get that 1. And in the middle, I'm going to need a minus and a minus. The negative 1 times negative 1 is positive 1. And I have a negative 2 cosine x minus 1 cosine x. And that does get the negative 3 cosine x. So you can factor a trinomial like this, you can factor it just like you did when it wasn't a trig function. Just in place of your variable, you'll just have a trig function. Same thing though. So now we have 2 cosine x minus 1 is 0, or cosine x minus 1 is 0. This piece gives us cosine x is 1/2 when you move the 1 over and then divide by 2. This side gives us cosine x is equal to 1 when we just move that 1 over. Over here I'm thinking quadrants. Cosine is positive in quadrant 1 and 4. The reference angle is pi over 3 because cosine of pi over 3 is 1/2. So from that piece, I get x is equal to pi over 3 and 5 pi over 3. Over here, cosine is 1 at, I'm thinking of the graph of cosine. Cosine is 1 at x is equal to 0 and x is equal to 2 pi. So I add those to my solution list and I'm done. Okay, what values of x in 0 to 2 pi are solutions to this trig equation? Okay, you guys avoid dividing by a trig function when you're solving one of these. Avoid it, because if you do, you're going to lose an answer, possibly 2 answers, possibly 3 answers. So avoid dividing by a trig function. Just like you should avoid dividing by an x if it's not a trig equation. Instead of dividing, I'm going to subtract that cosine over. We're getting 0 on one side. Okay? 0 on one side will allow me to factor what remains. I see a cosine x in common. I'm going to factor out that cosine x. Okay? I'm left with 2 cosine squared x, because cosine x times cosine squared x is cosine cubed x, minus 1. Cosine x times negative 1 is negative cosine x, and this is still equal to 0. So I have either cosine x is 0 or 2 cosine squared x minus 1 is 0. Well, this is the easier piece. What angles make cosine 0? I'm thinking of the graph of cosine, and cosine is 0 at x is equal to pi over 2 and 3 pi over 2. Over here, I have cosine squared x is positive 1 divided by 2. Move your 1 over, divide by 2. And then cosine x, if we square root both sides, don't forget your plus or minus. This will be plus and minus. I'm going to go ahead and rationalize. Plus or minus square root 2 over 2. Okay? All 4 quadrants, because we do have positive and negative. And the reference angle is pi over 4, because pi over 4 makes cosine square root of 2 over 2. So I'm going to add to my list of answers here, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And those are all my answers, all my solutions in between 0 and 2 pi to that trig equation. A couple more examples here. Solve this trig equation. So we have 3 tangent squared 2x minus 1 is equal to 0. Okay. So this is one where I just see a tangent squared. If I just see a trig function squared, I'm going to move all my numbers to the right and square root both sides, just like we did over here. I moved all my numbers to the right and then I square rooted both sides. So I'm going to move my numbers to the right. I'm adding 1 to both sides and then I'm dividing by 3. And now I'm square rooting both sides, putting my plus or minus. So I'll have tangent of 2x is plus and minus 1 over square root 3, which is square root 3 over 3, right? All 4 quadrants. And the reference angle, pi over 6, because tangent of pi over 6 is square root 3 over 3. We don't have just a plain x though, so I'm going to need to be careful here. 2x will equal the pi over 6 angles in all 4 quadrants. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. However, I put a comma because I have a 2x, which means I need double the number of answers here before I divide both sides by the 2, right? So I'm going to take my pi over 6 and I'm adding 2 pi, which is 12 pi over 6. I'm adding 12 pi over 6 to each of these. So this will be 13 pi over 6, 17 pi over 6, 19 pi over 6, and 23 pi over 6. Lastly, take half of both sides. And x will be pi over 12, 5 pi over 12, 7 pi over 12, 11 pi over 12, 13 pi over 12, 17 pi over 12, 19 pi over 12, and lastly 23 pi over 12. All my x values, none of which can be simplified or reduced. Last example. What are the x-intercepts of this equation from 0 to 2 pi? X-intercepts. Well, x-intercepts occur when y is 0, right? So we're setting this equal to 0. We'll have sine of 2x tangent squared x minus 3 sine of 2x is equal to 0. Okay? I have 0 on one side, so I'm thinking factor, and I see that each of these has a common sine of 2x. So I'm taking out a sine of 2x. I'm left with tangent squared x from my first term and a minus 3 from my second term, and this is equal to 0. So this means that sine of 2x is 0, or tangent squared x minus 3 is 0. Well, sine of 2x is 0. I'm thinking of the graph of sine. The graph of sine is 0 at 0 pi and 2 pi. So I'm going to have here 2x is 0, pi, and 2 pi, right? Since it's a 2x, I'm going to add 2 pi to these. So 0 plus 2 pi is already there. It's the 2 pi. pi plus 2 pi is 3 pi. 2 pi plus 2 pi is 4 pi. And then now I will take half of both sides. I'm going to write this over here. So x will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Right? Now for this piece. Tangent squared x is 3. Square root both sides, plus or minus. Tangent x is plus and minus square root 3. Quadrants, all 4. And what reference angle makes tangent square root 3? Pi over 3, single 3. So I'm going to add to my answers up here the pi over 3 angle in quadrant 1, the pi over 3 angle in quadrant 2, in quadrant 3, and lastly in quadrant 4. And these are all of the x values that satisfy that equation from 0 to 2 pi. And that ends our notes. That ends our notes for this whole unit, solving trig equations. We did quite a bit with them.